Exercise 2.1, question 1. The graphs of y equal to p of x are given in figure 2.10 below. So this is the label that we had in the book. For some polynomials px. So there are some polynomials px for which we have been given the graphs here in this question. Find the number of zeros of px, the number of zeros of px in each case. So what all do you need here? Well, you just have to know how do we find out the zeros of a polynomial, and first of all, what zeros are. So let's see this. What is the part that we have from our NCERT book? This is what they teach us about it. Let's read this together. Given a polynomial p of x of degree n, it could be any degree, right? Degree 1, 2, 3, anything at all. If you have a polynomial of degree n, then the graph of y equal to p of x, that is when you graph this polynomial, it intersects the x-axis at most n points. At most n points means a maximum of n points. Now each of these points where it cuts the x-axis or intersects the x-axis, each of these points corresponds to a zero of the polynomial. So this is the definition of a zero. What you really have to do is you just see where your polynomial intersects the x-axis. Each such point is a zero. For example, let's look at this first part here. You have this graph in the xy plane. The only thing you see is this line. Let me just mark this. So here is the graph of y equal to p of x in the first one. Well, this is a straight line, so I'll just go one step ahead and tell you that this one will have a degree of 1. It's a linear polynomial. Now what we have to do is find the number of zeros. What did you just learn? A zero is a point where the graph intersects the x-axis. Now does this graph, does this line intersect the x-axis at all? No, it'll always just keep going like this. It's a line, so you can extend it on both sides, but it'll exactly stay here parallel to the x-axis. So since it never intersects the x-axis, it will have no zeros as well. So the number of zeros that you are looking for is this. You have 0 zeros for this one. Let's look at part 2. This is again very simple. Just see where it intersects the x-axis. So it's intersecting the x-axis at only this one point. So this is what will correspond to the zero of this polynomial. So how many zeros it has? 1 zero. Let's go to the next parts. Just pause the video and try each of these parts now before you check my answers. Okay, I hope you tried. Number 3 now. How many places is it cutting the x-axis? 1, 2, 3. So how many zeros? 3 zeros. Part 4. How many places? 2 places. So 2 zeros. Very simple. Let's go to the next 2 parts. Yet again, try before you see my solution. Alright, part 5. How many points is it cutting the x-axis at? 1, 2, 3, 4. So 4 zeros. Part 6. Just 1 zero. Perfect. And here goes the last part. This time it's 1 here, 2 and 3. So the total number of zeros are 3. Now in none of the parts before this one did you have the graph just touching the x-axis. Well, even that counts. When we say intersect the x-axis, it does not mean that you have to cut it and go across to the other side. What I mean is this, that if this is your x-axis and your y-axis, the xy plane, it's not necessary that your graph has to go like this for you to call this an intersecting point. Even if your graph just touches the x-axis somewhere, that's also where it intersects, and so we'll also count that as a zero of the polynomial. And we're done.